Okay. What do we do?
So we switch Mg with Na.
Yes, we switch Mg with Na. Very good. Taylor, give me one of the products. If we switch Mg and Na. Mg is now with OH. Good. And go ahead, give me the other one.
NO3
Metals come first. So NaNO3. There it is. Except now we have to look at their charges.
Wait, how come it's not in parentheses anymore?
We can put it in there if you want.
Well, that was bothering me because I wrote it down twice. I didn't know.
You're supposed to, because that's what I told you, but I don't because I don't follow my own rules. But here's the deal. It's here because there's a 2. I didn't use it because there's no subscript there. So technically, if there's no subscript, we don't need it. Like right here, OH is on table E. It doesn't need parentheses because there's no subscript. However,
But could you write it?
yeah, if you want to do that, that's better. If that's a habit of yours, do it. It's better. So let's look at charges. What's the charge on Mg? Positive what? 2. What's OH? Negative what? 1. So Nicole, if this is +2 and this is -1, what do we need? If this is +2 and this is -1.
Make that 2.
We need 2 OHs. Very good. That's what you meant, right? Yeah. 2 OHs. Good job. And this is +1, -1. We're good to go. Let's balance it. Xavier, let's balance it.
FB2 from the NaOH.
2 here. One more 2 somewhere. Yeah, very good. 2 here. All right, let's label aqueous and solid. Take a minute or so. Probably a little less, but go ahead. Look up table F. MgOH2 and NaNO3. Which one's a solid? Which one's aqueous? This time there is a solid. It's not a trick question. Actually, wait a second. I might have made a mistake, but that's okay. We can still use table F to practice. Oh, okay. No, we're good. It worked out. I didn't make a mistake. I couldn't remember. I have most of that memorized, but some of them I forget. If you take AP Chem, you gotta memorize all this business.
Yeah,
And I can cheat, I'm a teacher. What?
Memorize it?
There's no reference tables in AP Chem, so you have to basically memorize all of these.
Why don't you just go and grab the reference tables? That's for regular chem.
Well, you can't use them on the AP test, so wouldn't really help you.
There's an AP test? Oh, it's called AP Chem, but yeah, there's no AP test.
All right, MgOH2 and NaNO3. What do we think? Jenny?
MgOH is solid.
Very good. That's solid. That's aqueous. Here's why. OH minus is on the right side. I thought Mg was an exception because I know a lot of group 2 with OH are soluble. Ca, Ba, Sr, but so Mg is not. Mg is insoluble, so that worked out for us. All right. Okay, so we're done with that. We're done with writing reactions. Down the road, you will have quizzes or tests where you need to know this stuff, but right now we're done with it, and we're going to start something new. What do we have, 10 minutes? Yes? 52?
Yeah.
Perfect. All right. Okay, so one of my favorite words, stoichiometry.
Spell it. It has to do with.
Stoichiometry.
Wait, say the whole word again?
Stoichiometry.
Does that have to do with geometry?
Nope.
Alright.
Have you ever heard the word stoichiometry before?
Oh, yeah. It's about the guy that invented it. His last name was Stoic. Or Stoke, or something like that. So they kind of just like put it together.
Write it down, please. Stoichiometry. That's an M, but it got a little squirrely there. If you understand what ratios mean, or what a ratio is, that's all stoichiometry is. Let me summarize. Stoichiometry uses mole ratios in a balanced equation uses mole ratios in a balanced equation to determine relative amounts of reactants and products. Yeah, it's supposed to be in there. That may confuse you, but that's okay. Mole ratios in a balanced equation. What does that mean? The big numbers in front, right? 2s, 3s, 4s, the coefficients. To determine relative amounts of reactants and products. So basically how many or how much reactants or how many products you have. How much of a reactant, how much of a product. So I'm going to use an example that everybody can relate to. Pancakes. Everybody likes pancakes, basically.
Let's see what happens. Did you
Apple pancakes.
Apple pancakes, yes, we're going to make apple pancakes. Oh,
Christmas in 3 days, man.
that was fun. Just leave it. No, Jake, just leave it. Leave it. Just get it later. Thanks. Okay, so apple pancakes. We're going to make them from scratch. What do we need?
We need pancake mix.
No, from scratch, meaning you don't have pancake mix.
I never make them. You need eggs?
All right, we need eggs.
Yeah, they only cost you $1. So.
Go ahead. You're going to write this down here. So we got eggs. Put them all the way on the left side of your page. You're going to kind of drag this out here. What else?
Flour.
Flour.
That's major.
What else?
Baking stuff.
Yeah, you don't really need that. We could, but I'm going to say no.
Oh,
Apples.
a little bit of cinnamon.
We need apples.
Cinnamon apples are good, so why not cinnamon apple pancakes?
You're missing a key ingredient here.
Milk.
Yeah, milk or water, but who uses water? No.
No one uses water.
Right.
That's
You're
what
an
you
American
use
if you use water.
with the
You say un-American?
Yeah.
That's funny.
Wait, you're
Let's
not supposed to
say-
use water?
What?
I thought that you mixed the water with the pancake.
Bro,
You can mix it with milk though, and it's like they're thicker, fluffy. They taste better with milk.
I didn't know that. It's not on the box. How am I supposed to know that?
Try it.
Bro,
How much
You'll
milk
never
do I
go
use?
back.
He's got a Soviet flag in his
How
face.
much? How much? I use the same amount of.
How many pancakes you want to make?
Like
25.
25. All right.
That's sick of-
Can we give me a whole? Give me a. How
Right.
An even
Uh,
number? 24.
am I gonna say this? Not a 5, like a number that an even number.
6.
4.
26. Okay.
Yeah, that extra.
I don't know why I couldn't get that out there. Pancakes. All right, 26 pancakes. How many eggs do you think we need to make 26 pancakes?
6, probably.
6? That's a lot of eggs, but all right. 6.
Well,
How
we
many
like
cups
eight.
of flour?
4.
4 cups of flour. That might be sort of maybe, I don't know. How many apples?
7.
Okay. Give me even numbers. It's gonna make the it makes the analogy easier.
8 apples.
All right, 8 apples. Okay. How many cups of milk?
12.
We want 30 cups of milk.
8 cups of milk.
6.
8 cups of milk. 6. All right, maybe 6. I don't know.
No, what are you talking about? We gotta make 26 pancakes.
You know,
That's
I
a
didn't
lot
write
of
this
milk.
like an
6
equation.
cups. Or maybe I'm wrong. I don't know.
I normally use like
Okay.
a half gallon of pancakes. And I only make like
You said you don't use milk.
Half gallon of
I
water.
only use a half gallon of water.
You don't
so I
even-
would transfer to milk.
Okay. So, hey, what I'm trying to show you here is that you have a little fun with it. This is essentially like a chemical reaction. You have your reactants and you have your products. So this is the analogy I use to teach stoichiometry. If we want to make 26 pancakes, let's assume these are accurate. We need 6 eggs, 4 cups of flour, 8 apples, and 6 cups of milk. I realize I didn't write cups or whatever. But,
I think you need more flour than you do eggs.
yeah.
No.
Well, anyways, just stay with me.
Because the eggs
Hey,
they really bring out the
don't
flavor.
go off on a
Extract
tangent.
the flavor of it.
Focus. If we wanted to make 52 pancakes, what would we have to do to all of these?
Double it.
Double it.
You wouldn't have to do anything.
What if we wanted to make 13 pancakes?
You have to divide
Keep
it
it just
two.
like that.
You'd have to divide all of these in half, right? So if you've ever cooked anything in your life, stop talking. If you've ever cooked anything in your life or baked, maybe you haven't, but if you have, you realize you want to change the outcome, the amount, you have to change what you put in the bowl or pan or the ingredients. Does that make sense to everybody? Yes. That's what stoichiometry is. Except, this is easy to understand and fun because we like this stuff and we eat it. Chemicals make it more confusing. In other words, instead of eggs, it's silver nitrate. Instead of flour, it's sodium carbonate. And instead of pancakes, we're getting, you know, potassium permanganate. I made up these chemicals. But the point is, once you see the chemical equations, it's the same thing as I'm talking about right now with pancakes. It just seems harder. So the questions you're going to see, we're going to do at least one example in our notes and the homework going to practice, is what if I wanted to make 10.5 pancakes? I know that that's a weird number. That's the point. Hold it. If I wanted to make 10.5 pancakes, and I wanted to know just one of these, in other words, how much flour would I need? Forget the other ingredients. I just want to know how many cups of flour I would need to make 10.5. How would we figure that out? Show me.
Flip 26 over 4 and then 3 equals 1.5 over x.
Perfect. I'm going to flip it, but it's just the way I think, but you're right. 4 cups of flour produce 26 pancakes. So how many cups of flour, or x, would produce 10.5? What's this called? Proportion and ratios. That's what stoichiometry is all about. Ratio of moles. So we're going to say 6 moles of eggs, 4 moles of flour, 4 moles of apples, 6 moles produce 26 moles of pancakes. The concept here is whatever we do next, it's not any harder than this. This might be a little confusing for some of you, but I use the analogy to help you kind of start, slow here. All right, so hopefully it makes some sense that if we have less pancakes, we're going to need less flour. So definitely that's going to be less than 4. Okay, so we're going to be using this as the way to learn this stuff. Okay, proportions and ratios. Let me give you a real example, chemical example, and then that'll be it. Okay, so here we go.
You know what? You're a lot closer. It's the first time I've missed in 3 days.
All right, write this down here. Let's go with, we'll make some water. H2 gas plus O2 gas yields H2O gas. You got a 2 here, you got a 2 here. There's your equation. Sorry.
Bro, you couldn't pick that up, man. You were right
Yeah,
there.
I mean,
you
what?
kidding me?
What?
Wait,
Okay.
take a seat.
I didn't see.
You're gonna run out of time. You're doing all this stuff that's not important right now. You can do it after class. Just take a seat. Get this down. All right, so there's your balanced equation. Here's my question to you, for you. How many moles of O2 gas are needed to produce 3 moles of H2O? You don't really need a calculator. I handed them out earlier today, period 2, but they didn't. It's the same question basically. You don't need it. You should be able to do this in your head. I mean, write it down, but you don't need a calculator. This is exactly what the homework's going to be asking. Similar question. The reaction that I gave you has a mole ratio of 1 to 2. Brian, you with me? Don't zone out. Don't zone out. You have 1 mole of O2 producing 2 moles of water. The question is changing that. So this is like, okay, 2 pancakes, well now we want to make 3. So we need more reactants, we need more ingredients, right? So 1 isn't going to produce 3. You have to figure out how many moles of O2. It's going to be more than 1. And you have to show. You have to show some kind of work. You can't just write an answer off the top of your head. Even if you can do it in your head, you always got to write something down. I use ratios, I use proportions. That's how I teach you. Blake, can you set up a proportion for me? Well, if you can, it's okay. Well, I'll help you through it. Okay, so the pancake analogy there, I had the flour over pancakes equals flour over pancakes. We're doing the same thing. So we're going to have oxygen over water equals oxygen over water. This comes from here and here. This side comes from the question. So we have 1 mole of oxygen over 2 moles of water. So now what do I put on the other side? X. Where did it have 2? 3, very good. So, if 1 mole of oxygen produces 2 moles of water, how many moles of oxygen produce 3? Cross multiply. 1.5 moles is the answer.
1.5.
I hope that made some sense. Your homework is practicing more of that. The very last question on the homework is tough. Very last question on the homework is tough, so you can skip it if you have no idea how to do it. And that's it.